Okay, the problem we're looking to solve now is what's known as the horizontal sextant angle. Horizontal sextant angles are just as they sound. They're angles taken horizontally by sextant. Okay, so we've got a drawing here. If you imagine you're around this area here, you're on the bridge wing of your ship and the vessel's stopped. And you're looking towards the coastline and you can see a lighthouse, a conspicuous tower and a light vessel just off the coast. So we've got the coastline all along here, our lighthouse, our tower and our light vessel. So you hold your sextant horizontally, point it at the lighthouse and measure the angle between the lighthouse and the tower, which will be this angle here, and on our example we get 60 degrees. 60 degrees written there. We then get our sextant again horizontally, point the sextant towards the tower and then measure the angle between the tower and the light vessel, and the angle here that we get is 40 degrees. Okay, so at this point we don't know our position, but we've got this information here, these two angles that are going to help us plot our position by horizontal sextant angle. So let's see how we sort this problem out. And the first thing we do is create two baselines, and the baselines run one between the lighthouse and the tower, which I've drawn in there, and then we have another baseline running from the tower to the light vessel. So we've drawn two baselines. Now we look at the angles that we've obtained, 60 and 40. What we need to do is subtract those angles from 90 degrees. With a horizontal sextant angle problem, we always subtract from 90 degrees. So with this first one, we're going to subtract 90 degrees from 60, and that will give us 30 degrees. Then we're going to subtract 90 degrees from the 40, 90 minus 40, and that's going to give us 50 degrees. The next thing we do is get our protractor, and we place the protractor on the baseline. Initially we're going to look at the objects, the lighthouse and the tower. The angle we had was 60 degrees. We subtracted that from 90 and we got 30. So we're now going to measure towards the vessel, and when the angle is less than 90 degrees, we always measure towards the vessel. We're going to measure 30 degrees. And we're going to do that on both sides. So we place the protractor along the baseline, measure 30 degrees, and so we have a triangle here where this angle here is 30 degrees, and the angle there is 30 degrees. Now we know in a triangle we have a total amount of 180 degrees. So the angle here will be 120 degrees, which is 180 minus 30 minus 30. And it's interesting to note that the 120 degrees, this angle, will always be double the sextant angle. So we had a sextant angle of 60, we got 120. When we do the next one, we would get 80 degrees. So our next angle we got was 40, we took it from 90, so it gave us 50. So we do exactly the same thing. Place our protractor along the baseline, go to 50 degrees, and draw our angle, go to the tower, place the protractor along the baseline, measure 50 degrees, and we can see here the two angles here are 50 degrees, 50 on this side, 50 on that. 50 and 50 is 100 minus 180 leaves 80 degrees. So the angle here is going to be 80 degrees. which is twice the 40 degrees. Once we've got those, we get our compass and we place it on the intersection of the two lines we've drawn, and then we go to the tower and the lighthouse and we draw a circle. Okay? And the circle should touch both the lighthouse and the tower. So this circle we're drawing here, it will touch the lighthouse and the tower, and as we go around we get our circle, as you can see. We do exactly the same with our light vessel and tower. So again, light vessel, tower, draw our circle, and where our two circles cut each other is going to be our fix. So we've drawn one circle on one side, this circle here, centre circle there, and that is the vessel's position. Now we can also plot a third angle, and that's the angle between the lighthouse and the light vessel. That angle is 100 degrees. So if we take 90 degrees from 100 degrees, we get 10 degrees, or we could call it minus 10 degrees. Because it's more than 90 degrees, we draw with our protractor our triangle away from the vessel, in other words towards the land. So we've joined the lighthouse now and the light vessel. So we draw a line between the two of those, and then we measure with our protractor an angle of 10 degrees. And we then draw our line up on that side, get our protractor to the light vessel, again an angle of 10 degrees. So we've drawn our triangle there. These two angles here are 10 degrees. We get our compass, where the lines intersect, we touch our light vessel, our lighthouse, and we draw another circle, and as you can see the circle goes through our vessel's position. So we can always use this third circle to confirm the vessel's position. And that's how we solve the problem called horizontal sextant angle. I'd just like to show you as well typically how this question would be worded. So we've put it here, and the question would say that you measured the following horizontal sextant angles from your ship which was stopped. St Mary's Lighthouse 60 degrees, Stackpole Tower 40 degrees, Caldy Light Vessel. Find your position. So what that means is that from the lighthouse, which was here, you had an angle of 60 degrees to the tower, and from the tower to the light vessel the angle was 40 degrees. So that typically is how the question would be worded, and as we've just done before, we've solved the problem known as horizontal sextant angle.